Good afternoon. My name is Jaspreet Sunda. I'm one of the STEAM coordinators at Division of Instruction. And I want to say thank you for joining us at our first annual or our first monthly STEAM Bytes. I'm joined today by my partner, Jerry Song. So take it away, Jerry.
Good afternoon, all. Thank you for joining us on such a historic day as we inaugurated our first woman vice president. She is also the first woman of color to be vice president. How many of you as students now, or when you were once a student, thought you would grow up to be a firefighter, police officer, doctor, lawyer, movie star, rock star, or professional athlete? One of the reasons students choose these professions is because they see people in these professions, often in real life or on a screen. If you Google jobs of the future, you'll find the vast majority of the jobs that will be available for our students when they graduate are STEM related. The vision of STEAM Bytes is to open the world of STEM and STEAM careers to our students so that they can dream about becoming a STEAM professional and to provide support for our students and educators in helping our students achieve their goals. You may also be asking, what is STEM or STEAM? Well, the letters for STEM represent science, technology, engineering, and mathematics. STEAM includes the arts as design and design thinking are required in many STEM jobs. But STEM and STEAM go beyond just a list of subjects. They are the intersection of the real world that our will be entering and the classroom that is meant to prepare them for it. It's also about empowering our students by showing them that they have the ability to solve real world problems in both their communities as well as globally. I'm proud to introduce Ami Bigit, our first STEAM Byte speaker. She is an engineer working at PPG Industries, or Pittsburgh Plate Glass Industries. I can't imagine that many of you have heard PPG before, but did you know that it's a Fortune 500 company? In fact, they are the 180th largest company in America and has nearly 500,000 employees. I'm proud to say that my father, who passed away back in October from cancer, was one of them. He retired after over 30 years working as a research chemist. During his time there, he received 2 patents for his work. So again, I'm especially proud to introduce Ami Bigit to speak at our first STEAM Bytes. I'm also proud to introduce her as she is a graduate of LA Unified. She graduated from Reseda High School and later went on to UC Berkeley, where she graduated with a bachelor's degree in science for industrial engineering and operations research. She now works in the Sylmar PPG office as a process optimization specialist. I'm sure that she will be telling us more about the specifics of what she does and the skills needed to do her job. Let's all welcome Ami Bigit.
Thank you very much for having me. Not only this is a great honor for me, but it's really exciting for me to be first of all the first speaker at this, which I believe it has like a great mission. I think that you guys are pioneering this team and that's extremely important, especially right now when so many of the students and educators are facing new challenges that they have never faced before, like not being able to be in the same classroom physically and rely on the traditional ways that we are accustomed for learning. So thank you very much for doing this, and it's a great honor for me to be part of this. So thank you for that. I'm gonna share my screen really quick and just kind of introduce myself a little bit. So as Jerry mentioned, my name is Ami Bigit. I went to UC Berkeley and graduated with a BS in industrial engineering and operations research. I currently work at PPG Industries as a process optimization specialist on the aerospace SBU, which I truly enjoy and I find really fun and very exciting because there is new learning opportunities every day. What do I do as a process optimization specialist? So I know those are a ton of big words, right? But I basically work in the manufacturing floor, making improvements So I'm an operational excellence leader. What that means is I need to lead in this industry, in this plant, to make sure that everybody is, doing everything they can to make improvements every day, little improvements every day that allow us to be, operational excellent leaders and achieve operational excellence, which is basically something that we do our job and then we complete our goals and we meet our KPIs, but in a way that makes us proud, in a way that we know that we're kind of like setting an example. So I drive continuous improvement by doing multiple things that relate to STEM kind of like just like topics, which is like determining inputs to key performance indicators. That's the KPIs I was mentioning earlier. Basically, we need to figure out what things affect them, right? So we can have productivity, which lets us know how we're doing in relation to cost, right? We need to manage the cost in the plant. So we look at productivity and we analyze our productivity and our scrap and our rework rates to just see how that affects it and put projects in place that allows us to improve. We analyze data and I help determine optimal solutions for us to just become better every day. I set strategies, implementation, and sustainment plans. This allows us to get to our goals in a very structured manner by selecting the right goals, first of all, and creating plans and assigning ownership to different team members so that we have a strategy and tactics that go with it that allow us to implement the solutions we come up with. I do some risk management and uncertainty management. Basically, whenever we are creating a new product or we have a new process or even processes that already existed, there's always the risk that something might go wrong. And there's always a risk that we just don't have enough information. So I also help by using some of my math skills and sometimes technology as well to manage that risk. For example, bringing in new innovative equipment that can monitor how much time a machine is up or down. That will give us the data that we need to analyze what projects to go after, what new technology to invest on, and just a lot of exciting things out there now in terms of innovation, but not everything is the right fit for every industry. So looking at that data really help us discern what are the good options for us. So how does some of this, how does science support the role that I have? It helps me understand manufacturing processes. It's very difficult to go out there and try to see how something is being manufactured if you don't really have a foundation in science. At our particular site, we make transparencies, which are mostly made out of basically plastic, acrylic, polycarb. And a few of them actually have some glass in it, but every material reacts differently to heat, to pressure, to other kinds of inputs. So having a background in science is really important because it makes my job a lot easier when I understand what's happening and why it's happening. It also helps us manufacture a part, figure out how to manufacture a part, right? Understanding science and the property of materials can help you determine whether you need to cut something by hand, cut something with a machine, and if it's with a machine, what kind of machine you should be using. Same with how to form parts or any other kind of manufacturing process. It helps us figure out what makes a particular material change its properties. So sometimes you can change physical properties of a material. Sometimes you can change actual properties that are more on how it's formed at a molecular level, which is more of a chemical change or just rearranging of the atoms, kind of like changes. And those are very, very important when it comes to how we treat materials. You know, like many of you might have heard of heat treatments in metals, which can make something very strong, but it could also make it very brittle. So a good background foundation helps us understand and get to our goals a little bit faster. Technology. How I use technology is by bringing innovation. Whenever we see an opportunity, we also research to see if there is a company out there that already has a solution for us. So being knowledgeable of technology and being comfortable with technology really help us assess what's the right technology for us to bring in. There's equipment that helps us reduce variability on both how to make a part or the quality of the part and how long it takes. And this is really important for some of our key metrics, which is like cost and on-time delivery. There's also technology that helps us keep people safe. For example, a machine, a CNC machine that actually cuts any kind of material to the specification, to the drawing, needs to be safe because it's a very powerful piece of equipment that can cut through very, very, very strong metal. So how do we keep our people safe? There's technology out there that allows for sensors so that the machine shuts down automatically if a person were to come inside of it. Or we also have kind of like sensors that let us know how we're manufacturing the part, if we're manufacturing to the specs or not. So how do we bring in all this technology into making a part? So very important to become familiar with technology, how it works, and what kind of technology is out there. And to be honest, it's probably one of the most fun parts of the job. Who doesn't like going to see something that they've never seen before, a big piece of equipment that does wonderful things that we can't truly understand, but we're being given the opportunity to go and benchmark it and talk to the people that create it and have them explain to us how it works. So it's very exciting to work with technology any day as an engineer because you're always constantly learning. Engineering, obviously, because of the design of processes and systems, which is something that I specialize on, but also design for manufacturing. How do we make something more profitable or easier to make? How do we make, you can cut costs from a part by making the process better, but you can also do it by making the design better in such a way that processing is a lot easier because the part is a lot simpler. Art is actually a very interesting one because I used to think that art didn't really come into play when it came to engineering, but I was wrong. Nobody likes to be looking at something that is just not nice or visually pleasing, or most of us are inclined to purchase things that look pretty, that look nice. So think about it like your phone. Your phone is technology, but there's an artist out there that designs how your phone should look, how the line should look, if it should be rounded or if it should be more square, based on what people prefer. Same thing with when it comes to almost any kind of product that you manufacture. You're still kind of catering towards a customer. So the artistic part, and it also comes very handy when it comes to workmanship and being able to identify what would be a good condition, how our customer would like to receive their products. And definitely very math heavy, my particular position. I do a lot of data analysis. I use statistics as a tool to predict outcomes or to model systems, as well as to just verify my answers, what I think is the right answer or the right solution is for something. I also need it on a daily basis for any kind of basic drawing reading or any basic or advanced measurements. How some of my coworkers use this. I work with many other people that also have either engineering degrees or math related degrees. So for example, finance. They use their math skills for like finances and calculating how profitable the company is. Some of my engineer friends and colleagues use it to set tolerances, basically to tell me what the minimum and the maximum of each measurement should be. They use statistics for doing things like the set of experiments, which allows us to, understand how different inputs affect our output. Developing CNC pads, like I was saying earlier, basically numeric control kind of programming that allows us to make things to spec automatically. Also to develop things like pads for robots. Math comes in very useful. As a matter of fact, a lot of geometry is required for that. How we use science would be things like I was mentioning earlier, like any kind of like heat treatment or any kind of treatment that we need to manipulate the environment in such a way that it can change the properties of the materials that we're using. We also have people that are chemical engineers that, and some of them chemical PhDs, that help us come up with new coding systems that basically give us a competitive advantage. It gives us an edge against some of our competitors. Technology like Industry 4.0 is something really exciting, which is basically incorporating the level of technology that we have already incorporated into a real day-to-day life, into manufacturing environment, so that we can know real-time information that we need and we can react appropriately to it. And as you transition into that kind of like Industry 4.0 mentality, making things more automated. So not only it gives you the right information that you need, but it also knows what decision needs to be made, and that decision can be automated. That action that comes out of that decision can be automated. We also use it to create value for our customer, basically develop new products. And we use engineering also to design tools and design kind of like the parts that we're going to manufacture and how we're going to manufacture it. So we have multiple kinds of engineers, like mechanical engineers, manufacturing engineers, chemical engineers. We also have a lot of scientists, like material scientists. And we employ very many people that are very good with supply chain as well, and operations research, and basically many different disciplines that use all of these concepts. So that's how it gets used across all of PPG. And I'm sure there's other positions out there that I'm not mentioning right now, but all very exciting as well. A little bit about my journey. So I started, as Jerry said a little bit earlier, I was an LAUSD student. But before I was an LAUSD student, I was actually an immigrant. I moved here to the US when I was approximately 16 years old. I enrolled in ESL, I was kind of like that typical student that most people would look at and say, she's probably not going to succeed. She doesn't even speak English yet. Luckily for me, I actually met this amazing ninth grade English teacher, Mrs. Rittinger, who saw something in me. She saw my willingness to work hard for what I wanted, and she saw that I had some potential. And she was able to basically encourage me to keep going and introduce me to multiple people, including Mr. Rittinger, who was the physics and robotics teacher at the time, as well as the science magnet coordinators. So I then joined the science magnet program, which was a great stepping stone for me. I cannot say just how much those kinds of programs really help open the eyes and focus students on some of the science stuff that you otherwise wouldn't be exposed to in other regular regular curriculum programs. By bringing more advanced tools and bringing more focus and more hands-on activities. So I'm definitely very grateful that the school I was going to had that particular program, because as you can imagine, as an immigrant, I didn't even kind of know that how any of that worked, and I would have never known to apply for it by myself otherwise. Once I got introduced into the Reseda Science Magnet, one of the things that I absolutely love how some of the administrators did is, and again, I had already met Mr. Rittinger, is how they let the students know, make sure that we knew that we had opportunities there. Like when they formed the robotics team, I was able to join it, and I was able to learn just hands-on kind of experiences, hands-on kind of knowledge, and most importantly, that feedback loop. When you're learning something from the textbook, it's very difficult to not notice little details. But once you're doing something yourself with your own hands by actually experimenting with the different properties, you start to learn it just at a deeper level. So that was definitely one of the highlights of my high school years, was being able to have that opportunity. One of the first opportunities that I truly had to have something hands-on and have that feedback loop of how my design was performing based on how I thought it would perform in my head versus how it actually performed on the field. I also joined Engineering Pathways, which is a program that was barely starting at the time, where they basically had a little bit of a curriculum that was a little bit more focused in engineering and have a little bit more, basically background in physics and programming and other things that we needed for robotics as well. So again, it was kind of like a mix of just getting knowledge as well as getting hands-on experience. So that was very crucial for me as well, because it really, really cemented what I already kind of knew. That is that I absolutely loved engineering and that I wanted to work with something that requires science and math, for the rest of my career. So it was very important for me, because that's what helped me to get the courage to actually go for basically an engineering degree. After that, I actually did a couple of years in community college, because as many of us know, that's kind of like a cheaper option in some time It also allows us to stay living at home a couple more years, which for me was very critical because my parents just couldn't afford to pay for the university and, a dorm room or any of those things. Um, I saved some money. I had an opportunity to apply for very many scholarships. And then I applied and I got into UC Berkeley, where, again, one of the best things that could have happened to me. I got to meet an amazing network. I got to gain perspective by being able to do some study abroad and travel the world and learn about entrepreneurship, learn about other societies. And it was just very, very exciting for me to be part of a research university and, and the number one public school. And it was just a very good experience because it was a good combination of very theoretical type of things that we did, but also how do we apply all this theory? How do you move from theory to something more real? How do you use research in order for you to learn more about, more in depth of anything that you're studying? And I think that was a great combination, being able to do some hands-on projects, being able to lead projects with basically within the industry, getting to know more people and getting to have a network and just being able to put all that knowledge into play, which is what really, really helps you consolidate kind of your learning. So that was very exciting for me. And I think it was definitely a pivotal point where I decided I want to work in manufacturing. I absolutely love to be hands-on. I absolutely love to see the problems firsthand. I love to collect my own data to have a sense of what I should be working on. So that's just kind of like how my formal education was. My career path was a little bit more conventional. I became an industrial engineer, then I transitioned to a continuous improvement engineer, manufacturing engineer, and now a process optimization specialist, which kind of is a combination of the last three. But as you can see, just because you study for one particular kind of engineering doesn't mean that your path cannot grow from there as well. There's always opportunity to grow. There's always opportunity to learn. And that's probably the most exciting part about being an engineer is that there's just so many possibilities that I just wouldn't have those opportunities right now if I had not gone through that path. I like to share a little bit of advice of what has helped me and some things that I also wish I knew before. And I've kind of like color coded it because I wanted to have a little bit for administrators, what you can do as an administrator, a little bit for teachers, what you can do as a teacher that has helped me, that I know that teachers that I've had helped me through doing that, as well as what you can do as a student, since you are the primary person responsible for your own future. I think exposure to knowledge is extremely important. We can facilitate as parents and as administrators, we can facilitate access to information. How can we do that? Maybe by just letting people know when there is any kind of like career tap event, maybe by letting people know some resources, or by what we're doing right now, sharing this link right now so that students can be exposed to what kind of careers are out there. We can include advanced topics in the curriculum as teachers. Teach to accommodate multiple learning styles. Not every person learns the same way, and just because they learn in a different way doesn't make them any less capable of learning. Sometimes we need to make sure that we understand our audience and accommodate to them so that we can include everybody in the classroom. As a student, taking ownership by doing research about the topics that you love, not waiting around for somebody to come and tell you something about it. We have at our disposal internet, which is crazy if you really think about it. If we think about 2 generations back, nobody had all the information that we have at our fingertips. So instead of spending so much time on all the other things, which again, they're fun, we should spend some time doing it. Spend a little bit of time doing that research of the things that you love, which includes what are the career paths that can take you there? What is the technical knowledge that you need to learn? Early exposure to knowledge is extremely key. The more you're exposed to something, the easier it is to learn. So it is important that you put yourself in a situation where you are not spending, you're not seeing things for the first time when somebody else has presented it to you, but actually proactively learning ahead of time. exposure to hands-on experience. Apply for grants as an administrator, as a teacher, making sure that we revise budget to include hands-on experiences like robotics or science labs. As educators, creating curriculums that include STEM hands-on experiences, or maybe even using household items to demonstrate STEAM real world uses. A lot of the times, like some of the greatest educators I've seen do experiments with the cheapest stuff just to highlight what students could be doing. Lead and participate in hands-on projects, research use of concepts you are interested in, and try to apply them at home as a student. A couple more will be goal setting. How do we support students through goal setting, making sure they're doing SMART goals? And how, as a student, I can figure out what my ultimate goal is and create the goal that supports my dreams. Ask myself, what would make me happy if I did that every day for the rest of my life? What would make me happy, and set goals that can get me there. Facilitating the creation of SMART goals with your students is extremely important. Also, and most importantly, a structured, committed approach to goal achievement. A goal is nothing but a pretty idea until we have an action plan. It's nothing else but a pretty idea. How many times have we heard people that said, oh, I had the idea for that business, that person just got to it first? No, they didn't. Were you working on that idea? When it came to your mind, did you set a goal? Did you set a plan to get there? Because if you didn't, that person didn't beat you there. Everybody might have had the same idea, but it doesn't mean anything until you put in the work. So it is important for us as, parents and educators and admin, basically admin people, to facilitate access to resources, ensure there is monthly and weekly activities that support our students' goals, provide constructive feedback. So not just saying what something was done wrong, but how can it be made better? Coaching students on how to deal with specific challenges that they're having. And for the students, you need to set your milestones. You need to structure your days around what you need to do in order to reach your goal. What are those activities that you can consistently do every day or every week or every month that can get you a little bit closer in a manner that makes you proud and in a manner that is achievable? Because I am fully aware that not everybody has the same life. Some of us have had to work. Some of us have had responsibility with maybe younger siblings or nieces or nephews. Some of us don't really have the same level of support than others, but it is up to us to create a path that's attainable for us, that is going to help us achieve our goals in a way that we're going to be proud of ourselves when we're done with them. And lastly, I would like to say that creating a network as well as believing in yourself are two, in my own personal opinion, the key to this. We need to provide settings in which our students can network, right? As teachers and as admin, creating clubs or creating places where they can meet people that are already professional, where they want to be at, so that they can ask questions and network. But there's other kinds of network as well. Finding peers that may have the same interest as you, or finding peers that have different interests that complement your interests very well. Being able to create your own club, being able to spend some of that time with your friends, actually learning something or actually creating something or starting a project to help the community. What are ways that you can leverage your network so that you can learn from there and they can learn from you? Join a technical team. Figure out how you can include technical, skills into your everyday life. And most importantly, believe in yourself. Remember that every situation is different. So be aware of that when you're comparing yourselves to others. Other people might have had more resources or less resources. And that's okay. We all start at a different place, but that doesn't change the fact that we cannot get far ahead. Just make sure that you're building that foundation. Educators and teachers, please make sure that you're providing that constructive feedback and knowing that every person has potential. The students, you need to know that you need to believe in yourself, otherwise nobody else will. You need to invest in yourself. Otherwise, why should anybody else invest in yourself, in you, if you're not willing to invest on yourself? And remember that self-doubt is your worst enemy. one thing that I always like to emphasize to my daughter is whenever you're struggling to finish a problem, this is especially for math and science, um, all that energy that you're spending feeling bad about yourself or doubting yourself or doubting what you can accomplish is energy that you're not spending on solving the problem. All that energy and all those thoughts are consuming part of your brain that you could be using to solve the problem. So we need to learn how to manage ourselves emotionally so that whenever we feel like something is too difficult or I can't get through it, the first thing is converting all that energy that makes you feel tired, it makes you feel like you can't keep going into energy that actually pushes you forward. Convert that into fuel so that you know what you need to do next. That if there's one piece of advice that I really want you to hold on to is that believe in yourself and change all that self-doubt into actions that will help you get where you want to get. And again, for any kind of person that's listening to this, that is part of that support system of a student, I'm forever grateful for the teachers that I've had on my path that have believed in myself more than I ever really believed in myself. And thank you for keep inspiring me and encouraging me and knowing that despite my circumstances, that I also had a chance. I'm so grateful for my mom and for my siblings who always believed in me and always said, you know what, I've always known you're smart. I've always known you're a hard worker. Let me know if there's something I can help you with, even if that moment they didn't know how to support me. They were always there with encouraging words. So it's really important to support others by giving them access to resources and hands-on experiences, but it's equally important to support our students by teaching them to believe in themselves. So that's all I have to say. And thank you so much for inviting me to be part of this. Like I said, I'm very happy. I'm very proud to be here. It feels amazing to be doing this right now because as they mentioned earlier, I'm an LAUSD grad. So I was in your seat not too long ago, I don't get more demographics of LA. I'm an immigrant, I'm a female, I'm Hispanic, I'm just like you. I've had those challenges. I also didn't have the support system that a lot of you don't have. But that doesn't change the fact that if we work really hard and we believe in ourselves and we build a good network, that we can also get there. So thank you so much for giving me this opportunity to everybody. Thank you to all the teachers. I know that a couple of them are watching this, so my old teachers in high school. So thank you so much, guys.
Thank you, Ami, for being our first speaker. And I do want to say, Ami, I'm glad that you gave a shout out to your teachers and Reseda High School because, as teachers, as an educator, you make us proud. This is what, our future is to see our students grow and, be successful in life. So an applause to Reseda High School and the teachers. I do want to say thank you to our viewers today. I hope each one of you have gained something from Ami's presentation, either gained something as a learner, as a student, or even as a support provider to our students, because this is what STEAM Bytes is about. It's about ensuring that we're here for our students as well as, our LAUSD community, because we are a community. We need to make sure that each one of us support not our students directly, but all of the students in LA Unified. So thank you for watching. I do want to make sure that you do sign up for February's talk. We have Captain Barrington Irving, who is the first African-American and the youngest man to fly around the world on his own, and he is a Guinness Book World Record holder. So he will be speaking in February, and please register at the same link that you registered for Ami's. If you have any questions about the STEAM programs in LA Unified, please contact Jerry Song or myself. I'm Jaspreet Sunda one more time. And we're here to support the LA Unified community. So thank you, Ami, and thank you everyone for watching today, and hope to see you in February.
I forgot to mention, thank you very much. And we also have some grants available for some of the schools at PPG. So Jerry and Jasper will be able to help you with that. They have more information. They have my contact information. So if you're an educator and looking for some grants to do some of this, like kind of like some hands-on activities that I was discussing, we have some grants available. PPG also provides some scholarships to students, and I've sent them that information as well. So please, please, please feel free to use our resource, use us as a resource. We want to partner with the community, and yeah, thank you.
Thank you, Ami. Yeah, that was wonderful. And it was so nice to be able to see, again, how what students are learning right now in the classroom actually impacts what they're going to do in the future. Because as you were talking about what you're doing now in a STEM themed career, I could see, students studying the same things in their classrooms right now. Thank you.
So once again, thank you for watching, and we will see all of you again in February.